In this lesson, we're going to learn about ammonia. Ammonia is prepared in the laboratory by heating a mixture of ammonium salt with an alkali, for example, calcium hydroxide and ammonium chloride mixture. On heating this mixture, ammonia gas is produced according to the following equation. Calcium chloride, water, and ammonia gas are produced. It is very important that ammonia gas is dried quickly using a suitable drying agent of calcium oxide, because if it is not dried quickly, it may dissolve in the water that is produced and hence forming ammonia solution, and you may not end up collecting any gas. It is also important to note that ammonia is collected by upward delivery or downward displacement of air, because it is less dense than air. The apparatus in which the mixture of calcium hydroxide and ammonium chloride are heated should be tilted in order to prevent trickling back of water that has been formed into the hotter parts of the flask and hence causing it to crack. In the gas tube where we collect ammonia, it is important to place a moist litmus papers, red and blue. Since ammonia solution formed when ammonia gas dissolves in water is a basic solution, then the red litmus paper would turn blue, and that would indicate that the gas jar is full. Physical properties of ammonia. Ammonia is a colorless gas with a pungent choking smell. It is very soluble in water. It is less dense than air. As for the chemical properties of ammonia, ammonia reacts with hydrogen chloride gas to form white films of ammonium chloride, and this can be used as a confirmatory test for the presence of ammonia gas. The equation for this reaction is ammonia reacts with hydrogen chloride gas to form ammonium chloride, which is a solid and appears as white fumes. It is very soluble in water to form aqueous ammonia. The equation for the reaction is given here. Notice that gaseous ammonia dissolves in water to form aqueous ammonia. It retains its covalent nature, and therefore it can be said that a large percentage, about 99% of ammonia gas dissolves in water to form a solution of ammonia known as ammonia solution. However, about 1% of the ammonia solution formed dissociates in water to form ammonium ions and hydroxide ions. During this dissociation, you'll notice that it is a partial dissociation, because the reaction is reversible. In as much as ammonia dissociates in water to form ammonium ions and hydroxide ions in the forward reaction, at the same time ammonium ions and hydroxide ions actually recombine back and form ammonia solution and water. Since this reaction is reversible, it yields few number of hydroxide ions, making ammonia solution a weak base. More chemical properties of ammonia include: ammonia reacts with concentrated sulfuric 6 acid to form ammonium sulfate. This is also important during the preparation of ammonia because concentrated sulfuric 6 acid is commonly used as a drying agent, and therefore it cannot be used to dry ammonia gas because it would react with it to form ammonium sulfate. The equation for the reaction is given here. Ammonia also reacts with calcium chloride to form a complex compound known as tetraamine calcium chloride. The equation for the reaction is given here. You will notice that the product formed is a complex salt. Now, you might just be meeting this word complex salt, but it doesn't mean that it is complicated. It only means that the way that calcium chloride and ammonia combine is not usual, and therefore we call it a complex salt. Now, it is known as tetraamine because tetra represents 4, which is the number of ammonia molecules present in the compound, and amine represents the ammonia. Then you just say the remaining part of the salt, which is calcium chloride. Ammonia undergoes oxidation in 2 ways. The first one, ammonia burns in oxygen without a catalyst to form nitrogen and water. Since this is an uncatalyzed reaction, ammonia will burn in oxygen to form nitrogen gas and water. However, if we involve a catalyst, for instance platinum, ammonia will react with oxygen to form nitrogen 2 oxide and water. The equation could be given here. This must be taking place in the presence of a platinum catalyst. In case a platinum catalyst is not there, then we could use copper metal or nichrome wire. When a heated platinum wire is lowered in a gas jet full of ammonia gas and oxygen, it will continue to glow because the reaction is exothermic. Let us do some mind game or some exercises for our minds. The setup below is used to study the reaction between ammonia and oxygen in the presence of a catalyst. Now let us answer a few questions. The platinum wire continues to glow without further heating. Explain. Try and answer that question. Next is, brown fumes are observed in the flask. Explain. Also, try to answer that one as well. Next, write the equations representing the catalytic oxidation of ammonia and the formation of the brown fumes. Finally, state 2 other metals that can be used in the place of ammonia. Also reduces heated copper 2 oxide to copper metal, while itself is oxidized to nitrogen. The equation for this reaction is given here. Ammonia burns spontaneously in chlorine to give nitrogen and hydrogen chloride gas. When we say spontaneous, it means this reaction just starts off without any assistance. When ammonia is in excess, then it will react with the hydrogen chloride gas produced to form white fumes. The equation for the reaction is given here again. Ammonia is a very important solution, especially in the test for metal cations. In this lesson, we are going to study about how ammonia solution reacts with different soluble solutions containing metal cations.
We're going to find out what happens when aqueous ammonia is added to solution containing metal ions. In each of the test tubes you see before you, we have different solutions containing the metal ions as indicated in each test tube. At first, we're going to add a few drops of aqueous ammonia or ammonia solution. And finally, we add excess ammonia solution and make the observations. Let us begin with calcium on the far left. We're going to add a few drops of ammonia solution. Find that there is no white precipitate that has been formed. You can even bring it closer to see that there is no white precipitate. When I add excess of ammonia solution, and you'll still find that there is no white precipitate. And if I bring it closer, you'll see there is no white precipitate. The next one is magnesium. This solution containing magnesium ions, we begin by adding a few drops. When you add a few drops of aqueous ammonia and shake a little bit, you'll find that a white precipitate is formed. As you can see, on addition of excess ammonia solution, the white precipitate remains. Next, we have a solution containing aluminium ions. I add a few drops of ammonia solution and shake it a little bit. Find that a white precipitate is formed. On addition of excess ammonia solution, the white precipitate remains or persists. As for zinc ion, a solution containing zinc ions, on addition of a few drops of ammonia solution, we have a white precipitate that is formed. When you bring it close, you'll see it is a white precipitate. Then, when I add excess, then I shake a little bit, the white precipitate dissolves to form a colorless solution, as you can see. Next, we have copper 2 ions. Add a few drops and they form a pale blue precipitate. On addition of excess ammonia solution, the pale blue precipitate dissolves to form a deep blue solution. Upon addition of aqueous ammonia to lead 2 ions, a solution containing lead 2 ions form a white precipitate, which is very clear. On addition of excess ammonia solution, the white precipitate remains or persists. Next, we move to a solution containing iron 2 ions. When you add a few drops of ammonia solution, form that a green precipitate is formed. Shake it a little bit, you find that it is very green. Then on addition of excess ammonia solution, the green precipitate remains or it persists. As for iron 3 ions, a solution containing iron 3 ions, on addition of a few drops of ammonia solution, the solution turns brown. On addition of excess, the brown precipitate remains. Finally, to a solution containing barium ions, we add a few drops. You'll find that a white precipitate is formed. It is very faint. And on addition of excess, the white precipitate remains. Thank you very much. We've been adding ammonia solution.
With the experiment that we just did, we can conclude that the different metal cations have different observations and behaviors when ammonia solution is added to it. First of all, in a few drops, and then in excess. You can pause the video and study this table, and you'll find that it will be very instrumental, especially when we start dealing with what is known as qualitative analysis. Qualitative analysis will be used in our practicals, whereby we'll be using ammonia solution to test for metal cations. In order to understand the experiment that we just did and the sample of observations, we need to write some ionic equations in order to know what products are formed and which ones are responsible for the precipitates we observed. In the addition of aqueous ammonia or ammonia solution to solutions of metal ions, the ionic equations are given here. Firstly, calcium ion does not form any white precipitate because the calcium hydroxide formed dissolves, forming a colorless solution according to this ionic equation. Magnesium reacts with magnesium hydroxide. Magnesium ions react with the hydroxide ions to give magnesium hydroxide, which is a white precipitate. Similarly, lead ions react with hydroxide ions to give lead 2 hydroxide, which is also a white precipitate. Copper reacts with hydroxide ions to give copper 2 hydroxide, which is a blue precipitate. Iron will react with hydroxide ions to give iron 2 hydroxide, which is a green precipitate. Next, we have iron 3 would react with hydroxide ions to give iron 3 hydroxide, which is a brown precipitate. Now, in addition to excess ammonia solutions, all the other metals except zinc and copper would have no change because the precipitates formed are insoluble in excess. However, for copper, copper 2 hydroxide reacts with ammonia solution to give a deep blue solution, which is actually tetraamine copper 2 complex ions that are responsible for the deep blue solutions. Similarly, zinc 2 hydroxide reacts with ammonia in aqueous solution to form tetraamine zinc 2 ions, which are a colorless solution. It is important to remember how to write the formulae of these two complex salts. The uses of ammonia. Ammonia is very important in the society because it's used for various purposes such as the manufacture of nitric 5 acid. It is used as a refrigerant because of its high volatility. It is used in the manufacture of hydrazine, which is used as a rocket fuel. And it's also used in the manufacture of nitrogenous fertilizers like the one you see here, which is used all over the world for agriculture. It is also used in making synthetic fibers like nylon. It's also used in softening hard water.